Hey streamers. Hey Max Payne Life. Hello. Are you in from Australia? Glad you can make it. I'm very excited to be here myself. Cause it's kind of been a long week, so much going on in the world. It actually kind of takes my mind away from all the problems out there just to, go live, talk about some data. Oh yeah, so let me introduce the stream. My name is Carl Gold. I'm a data scientist from Silicon Valley, California. And this is my stream, Carl24K Data Science. And here I mostly talk about Python and SQL, and a subject called customer churn, which I'll tell you more about in just a minute. If you haven't seen my streams before, I usually spend a while at the beginning kind of like going over the background, giving everyone, kind of level set for everyone. So that's what I'll be doing first, and then in just a little bit, I'll be doing, live data science and coding and stuff, good stuff like that. So without further ado, let's get on with the introduction. What is churn? What am I talking about here all the time? As usual, sorry for boring everyone who knows this, but for everyone who doesn't, you probably want to know that churn is subscribers, customers, or users quitting. When they're quitting your product or service, and that could be any kind of product or service with recurring revenue, including paid subscriptions, in-app purchases, and ad-supported products. The origin of the term is from the churn rate, which means the percent of customers dropping out. But now churn is also a verb, so you can say the customer churned, or I'm churning from Netflix because I watched the last season of Schitt's Creek and there's nothing else I want to watch there. Just kidding. I started watching the Da Vinci Code on Netflix yesterday. They got some good old movies going on in there, so I haven't churned from Netflix. But churn is also a noun. You can say make a churn report for last quarter, or make a report of last quarter's churns, both of which is using the word churn as a noun if you think about it. And you can even say the customer is a churn if you know they already canceled. So that's what churn is. When you're in this business, we talk a lot about churn. For the rest of you, you might be like scratching your head, but now we've done the level set, everyone knows what churn is, and we're ready to move forward and ask, why care? Maybe I should make this slide say, why care about churn? Well, it's the most common data science problem in the world, I think, according to me, but I'm biased. Every company that is online today, which is pretty much every company, has a churn problem because they want their customers to come back and not defect to other services. So by learning this, you'll learn special tips and techniques that'll help you with the most common data science problem in the world. And it's also a great data science for beginners. If you learn data science from my book and from my streams, you do the churn scenario from beginning to end with an emphasis on real-life data handling skills, the kind you'll need to actually do this analysis at a real company. So hopefully that's what you find here, and hopefully you keep coming back. Once again, I'm going to get to the actual code in data science very soon. Just let me get through the rest of the intro. Oh yeah, this is my book, What is Fighting Churn With Data? It's a book that I wrote based on my experience as chief data scientist at a company I'll tell you about in just a minute. My book is from Manning.com. You can get the book on their website. It will be out on Amazon by the end of the month, and there's a 40% discount code right here. So hopefully the discount code makes it worth you listening to me spam you with my infomercial for my book. But you don't need to buy the book because this stream will teach you everything you need to know. What is Zora? That's where I got my experience on churn. It's a platform that many companies use to deliver their subscription service. For example, Zoom is a company that now also became a noun and a verb this year because everyone's on a Zoom, having a Zoom, starting a Zoom, Zooming with their friends. Anyway, Zoom runs their business on Zora. So that means that when they want to manage their customers or their subscription plans, they do that in Zora. And so that's how come I got the experience to work on many, many different companies' churn problems. Like a typical data scientist only works on churn at one company, but because of my time at Zora, I've worked at churn for many companies, and that's where I got the experience to write the book, which is supposed to save you from my mistakes. All right, after saying what is Zora, what else do I need to tell you? What is Fighting Churn with Data really? Not the cute title for my book. It's actually data-driven churn reduction, which means using your data to save customers. A few ways that usually happens. Making a great product is the number one. Make features and content that customers love so they keep coming back. And you can use your data to find the best product features without using customer surveys, which are notoriously biased. You can also charge your marketing by targeting customers with information they value. You can support your customers and figure out which customers need help, which is called customer success, when you figure out what they need and reach out to them. And lastly, you can adjust your sales and pricing so that all your customers get a value without giving out discounts. All right, I think that's all my level setting introduction. That's the domain knowledge, background, most of the domain knowledge that you need just to understand what we're doing here, why we're looking at this data, what's going on. All right, so there is code for this on GitHub. I'll mention this throughout, but it's my GitHub repo, Carl24K, Fight Churn. The setup instructions involves cloning the repo. It uses Postgres and Python. And this was in the stream, I think, from 2 weeks ago. So you can find this in the highlights. I have a highlighted version that goes through all this setup. You create schemas, you set up Python. If you haven't done it already, I use PyCharm, but there are different ways to do it. And then you run a data simulation. So we actually simulate data to do all this because it's hard to get a real company that will part with their customer data to let people use it for learning. Now there is going to be an opportunity to do that at my publisher, Manning.com. They are making their real data available for you to analyze in a project, but that's a few months away. Anyway, so for right now, you got the simulation. You can find this all on GitHub. And let's look at some data. Where's the data? Let's go and look at what we get from having run that simulation. Let's see, this is me in a SQL tool called Postico, which I use just for these streams because it's an easy way to, because this was a SQL query I was doing before. Maybe I should just go up and kind of show you the schema, or no. I'll do a select. Remember, so Fighting Churn usually involves subscriptions, or often. So we created subscriptions. And we made the simulation called SocialNet 1. And so I'm going to look at the subscription table first. Order by, I think subscriptions have start date. Yeah, there we go. They have a start date. And we'll limit that to 100 rows just to show you what the subscriptions look like. And these were created by the simulation. Okay, well, every subscription has an ID, and there's an account ID associated with each subscription. So each subscription is for one account, and it has a start date and an end date. These subscriptions also have a monetary cost, $9.99. It's kind of ignored. If you want to see a good example using those, look at my stream on Manning's channel from yesterday. I did a lot with subscriptions that had different terms. But for this simulation today, all the subscriptions just basically have a start date and an end date for each account. Now we also had event data. Let's see. I think we have event data also created by the simulation, and this is of special importance for today's stream because we're going to be working with this event data. So let's see. This doesn't tell you too much. You can see that each event has an account ID, a time, and a type, so that each event. Well, let's link these events. There's also a type table. I'm going to make an alias for event. I'm going to say inner join net 1 dot event type t. Just going to fill in this SQL. So we'll do a join on the type table that lets you see what these events actually are. So now you can see, I mentioned this is a social network, so you can see that these events have types that are the behaviors that people do on a social network, including posting, making new friends, viewing ads, etc., liking, posting, messaging. So this is the result of the simulation that you get, that I created for the book for people to learn these techniques. You start out with a table of subscriptions and a table of events, and that's basically the data that you would have if you were just coming to a churn problem at a real business where you might work or something. So let's see. I'm going to try to make the chat a little bit smaller here so that you can see more of the data. All right, how's that? Hopefully that chat just magically resized. So this is the data we've got. And what do we do with that data? That is what comes next. Because today we are well, first I have to tell you last week, I just put this in here so you know. Last week we did calculation of churn rates. And actually just yesterday on Manning.com's channel, I did another stream on churn calculation. So we're not going to talk about calculating churn today. We're going to go on to this week. Today's subject is metric calculation, and this means customer metrics. So customer metrics, I calculate them and I teach how to calculate them in the database. So a customer metric is like a summary. I'm going to go into all this in more detail in a minute. I'm just giving you, this is just the high level, first look. We're going to take the event data shown in this table on the left, which we just looked at, and we are going to write it into another table called the metric table. And in the metric table, it'll be a summary of the events for each customer. So each metric also has an account ID and a time and a value. So your events are like big data, which are stored in a data warehouse. I don't know how big they are. They're kind of medium data for the simulation. Let's take a quick look. If we do a new query, I can just select count star. We can see how big the event data really is. And we'll compare that to the subscription data. And this is just, the simulation is kind of modeled after kind of a small to medium business. So here we've got, 16 million events, and how many subscriptions? Whoops. Okay, 54,000 subscriptions, and this is for how many customers? I didn't tell you there's also an account table. 14,000 accounts or customers. So that's the data for this simulation. It's kind of actually medium size, I'd say 17 million events. But in general, your event data is going to be much bigger than your metric data, because the metrics that we're going to create are like summaries of the events. And that's what we're going to be doing, basically right now. Let me just say more about the concept behind the metrics. Which is illustrated here. The concept behind the metrics is you have events shown here on the top as two timelines. And imagine these are just login events. Actually, we didn't have any login events in the simulation, so maybe I should have relabeled this. But anyway, it's the same idea. Anything that the customer does on the product or service can be an event. So you have these different streams of events at kind of random times, essentially. And then we're going to make metrics. And the basic metric is a count metric, which means you count the number of events within a given window, which is illustrated with this drawing on the left. So basically, you just take all the events for each customer, and at a select set of dates, you measure the events in a trailing window. So if this were this example here on the left, the 29th of January, supposedly, this customer one had 2 logins in the last 4 weeks, so their metric value would be 2. And this other customer had 4 events in the last 4 weeks, and so their metric value would be 4. Do we use Postgres also in my company or also for this screen? No, I use it in my company. Not currently, actually. I used it on some projects earlier in my company. And now we're actually using mostly Athena on AWS, which is a Presto database. Fortunately, it supports a lot of the same style SQL. So we started out doing, and also we were using Redshift too. That's a long story. We started out with Redshift, then we moved to Postgres, and now we're more on Athena. I should say Presto. Fortunately, they support similar styles of SQL with just differences in some functions. So we didn't really have to change the SQL too much. But I got used to Postgres, and it's good for just having it on a laptop, because those other choices I mentioned, like Presto and Redshift, which are real big data databases, those don't run on your laptop generally, or maybe there is a way. Anyway, so yeah, we have used a lot of Postgres, but not so much anymore. Some projects still, and we're using RDS and like Aurora now for those projects. So let's see. So this is the metric concept. It's actually pretty easy if you like kind of heard all this before. So here's an example of a toy calculation of a metric. I don't even know if I need to go this basic, but suppose this is just for one account and one event. So I'm only showing account 1, event type 1. Suppose they have these events on days January 12, 17, February 3rd, 5th, etc. If you do period 1, you're basically going to count the events that fall in between the start and end date. So this account gets a 2. Period 2, you take these events that are all between the start and end date and count them to a 4. So are you thinking that looks like doing an aggregation on a table? Because this is like, the table on the left, and this here would be a new table on the right if we were doing an aggregation. Yeah, this diagram is like so basic, but hopefully it makes it clear that we're just going to partition the events into periods and then count them up. Now, that looks very tedious if you were going to do this account by account, like in a spreadsheet or even in a loop with Python. So what we're going to do is we're going to do this with SQL. And this is the main way that I teach to, count, to create metrics for customers is using SQL. So let us see, I'm going to go to finally getting into some code now. We're going to look at event count, which is SQL 3.1. Now, if you saw from the setup last week, I guess I left this kind of in the middle of something here. If you saw from the setup last week, I do this in PyCharm, and I have a configuration that runs all the listings using a wrapper program called Run Churn Listing. And it's basically will load my SQL from a file and put bind variables in it. Let me show you that actually. So this is, I said chapter 3 listing 1. So if you go to the listings folder, within it there's a chapter 3, and within that you just find listing 3.1. So this is what I mean by doing an event count with a SQL. And this is what I mean by a bind variable. It's a variable that starts with a % symbol, which indicates to the code that we're going to substitute that. That's just a little trick to help make the matching simpler. So we're going to bind in a date here, which is the day we're going to make the measurement. And then we're going to bind in the name of an event here. And that's going to tell it what event to measure. Now to run the code, in the wrapper program, I show people how to use these PyCharm configurations. I did some of these last week, and once you get started, as I showed in the previous setup, it's pretty easy because you can just clone your old configurations. So this was for running listing 2.1, and again, I showed how to set this all up in a previous stream. Now I'm just going to duplicate it, and I'm going to make the configuration for listing 3.1. Wow, I should really keep these in order, or maybe put the most recent one at the top. So to make it for chapter 3 listing 1, I need to change this parameter to chapter 3. And now this is going to run the SQL, which I guess I should just run it to let you see. And then we can go into more details of it. So this loads it up, connects to my database. Now it actually launched the SQL, and as you can see here, it's taking a moment. So let's look more at what it does. I actually like to take these and put them into the SQL tool to kind of dive into the SQLs. Okay, it just returned the result here. And you can see it's a little table of accounts and the number of events. In this case, it's the number of likes per month. And that is because listing 3.1 is configured to run for likes per month. So let's take the SQL here into the SQL editor. And then we can look a bit more about, look at it a bit more closely. I'm going to move this over a little bit just so I'm not covering up so much of the SQL. I think that'll be a little bit better. All right, so you can see we do a set search path, which is just to the schema that I'm using, and that's just that's actually a Postgres thing. So this one line is Postgres specific. The rest of this is standard SQL using common table expressions. So the metric calculation is very simple. It's just an aggregation here. So there's a group by account ID. So we're aggregating over account ID. We do count star and call that the number of likes per month because the event that we're looking for has the name like. So this counts the number of likes that each customer has per month. Hey, Max Payne Life, thanks for subscribing. Oh my God, a subscription. Wow. You're awesome. And I think you're my second subscriber. So welcome to a very exclusive club of Fighting Churn With Data subscribers. I hope I make it worth it for you. Yeah, thanks for congrats on making it to affiliate. And cool emote. I got to make emotes. Now that I'm an affiliate, I get to make emotes. I got that on my to-do list. So anyway, for the timing, note that the SQL selects events where the time is between the date, which is the measurement date. Here I just used one date. This is supposedly May 10th. And then I take all events within a 28-day interval before that. So it's event time less than the date and greater than whatever I calculate 28 days before the date. And there's a reason I do this all parameterized here. You notice how I only use, the date as a variable. So again, whoops. Hey, how did I mess this up? Regeneration event. Ooh, boy. I think actually what I have to do is run the set search path separately. Not doing too good here. I want to just run this set search path. Now it says set. Now let's try running the rest of the SQL. All right, there we go. It's running. I can actually see the little counter in the bottom right. It's a little bit clipped off, looks like, on the screen. But it's chugging away. And so, yeah, so that's basically the... Oh, cool. So you're a data engineer. I actually work a lot with data engineers. And the truth is, a lot of what we're doing in this stream qualifies as data engineering. I mean, you probably often heard, the quip that 80% of what data scientists do is the, data plumbing, data engineering. Oh, but it looks like the query returns. You can see it has given us a bunch of account IDs and the number of likes per month that they all had at the time. So count 1, 2, 3. So they all have a different number of likes. So these are, people who obviously like things by very different amounts. And that's what the metric is really showing us. So we know that metric customer 12, I can see, doesn't like a lot compared to, I've already seen there's a customer here who's liked more than 100 things. So that's why these customer metrics are like summaries. All right, so I think that's showing enough of the basic customer metric. Let's see, what did I have next? So that's how you calculate a basic customer metric. But the next thing that we're going to do is calculate the same metric for multiple dates. Now, suppose that this is your situation here, where we don't just want to calculate the metric once a month, because that's not very frequent updates. Like if you waited 4 weeks to update their metric, the customer might churn in between. So what you actually do is calculate the same metric on multiple dates at the same time without calculating it month by month. You could calculate it week by week. So then what you're doing is using what they call a sliding window. So I don't know if you've heard the term of a sliding window for a calculation. It's fairly common, in different fields, that they basically, you define a date for your calculation and you use all the data within a certain time window behind that. So in this case, suppose we're updating, showing here, this is like a March 12th metric update. It uses this window behind, lagged behind March 12th. And that's what goes into this one metric calculation. And in this case, I'm supposing we calculate metrics every week. And you could also do it every day. So this is a moving average, exactly. Thank you, MOSFET. We're doing, it's actually not a moving average now that you mention it. It's a moving sum. It would be an average if we divided it by the length of time. And we will do that like in more advanced streams. But I start out with just moving sums, actually, to be completely precise. And so you can see here, if you, like in the bar chart shown at the bottom, if you were to update the metric once a month with non-overlapping windows, that's what's shown in this line, you would get the green measurements. And you'd have to wait 4 weeks between measurements. And it would go like from 2 to 4 and back down to 2 for that customer, and then down to 1. But if you update the metric every week with the moving window, the sum, then you would get these in between calculations updated weekly. And then you would get the moving sum of 3 in between 2 and 4. It kind of tracks it up and down rather than just jumping from 2 to 4. You can see this is kind of like a more fine-tuned, moving calculation. And so that is the idea behind multiple date metric calculation. And here is the illustration of doing this with some tables, and it's showing how in this case, so in the single non-overlapping window metric calculation, each event went into only one window. But now in the moving window multiple date metric calculation, each event will enter into more than one window. In fact, because there's 4 weeks in a month and we're using a 1 month or 4 week look back period, every event will actually go into 4 different windows. And this looks like it would be really complicated. Maybe, oh my God, how could we calculate something so complicated? Well, it would be a pain to do this in Excel. No argument there. It would be kind of a pain to do it in Python, like in a loop. I mean, I guess you could do this like with loops. You'd have to make a lot of, do a lot of pandas data frame logic. But of course, the better way to do this is in SQL. Yay, our friend SQL for metric calculation. So let's go to the SQL. And we can look at listing 3.2. I think I'm just going to run it, and then I'm going to take the code that it prints out and put it into the SQL editor for further hacking. I think I'm just going to keep updating this one configuration. I'm just going to go over here and say, whoops, actually that's not working so well. Wow, I'm having some trouble actually editing off the edge here. Geez, never tried to do this in a stream before. Well, I need to edit this thing to say listing 3. Maybe I'll put the schema last, because you know what? That's what I'll do, is I'll put the listing first and the chapter and schema last, because I'm not going to keep editing those. Normally this is a lot easier, but I've got my PyCharm on this giant font, basically, and I've got it all squeezed into a little window here so that it's viewable, during the stream. So now it's kind of going off this edge. So this will be chapter 3, listing 3. I'm just going to hit it, and it's going to print out the SQL that it's running. And now we're waiting for the result again. Wait a second. I think I'm supposed to do chapter 3, listing 2. Yeah, we weren't supposed to do that one yet. Let's do chapter 3, listing 2. Let's see. Okay, so this is the first one. That was actually the wrong one. So this is going to be very similar to the last sequel, only now we're going to do it for multiple dates at once, which is the new trick. So as you can see, instead of selecting a single date in the common table expression at the start, now I'm selecting a range of dates, which this is actually Postgres specific too, using the date vals common table expression. So here, if I show you, let's just do select star from date vals. So this is just selecting what comes out of this common table expression, which is just a sequence of dates, 7 days apart, as you can see, as specified by the interval. So then, if we put the whole sequel back in, now we're going to run essentially the same query. Yeah, this is a Postgres benefit here on the generate series, but you can do equivalent things in just about any other database. Even if there's no generate series function like this, you could always make a table and just call it the date sequence, table, and just store the date sequence that you want in one table, and then you could, select from that table with the date sequence. You tried. Something didn't work. Well, I figured you could do this in a variety of ways on almost any database. Yeah, or I meant actually with a permanent table. Like you can just make a table in your schema and load it with a sequence of dates that you want to use, and then you can join with it when as necessary. There are somewhat similar things, not in MySQL. I don't know of one, but pretty sure in Presto, I've done it. You can do a date series in Presto. And I'm not really sure I think you can do it in Redshift too. Anyway, so after making a date series, this query is actually the same as the last one. The only difference is that now we select for a metric date and we group by the account ID and the metric date. All right, let me execute this statement. This one's going to take a little bit longer to run because instead of just calculating the metrics for a single date, we're now calculating the metrics for a sequence of dates. And it's actually many dates. I should have actually maybe limited this query a little bit before I ran it because now it's going to take a while. But not quite sure what to do about that. Let's see. Anything else to say about this query? But yeah, the time join is the same, but now we're joining on a series of metric dates, and because we're selecting the metric date in the group by, we're going to get one result per date in a few minutes here. Which is when it's good to be listening to the music. Let's see if this one finished. Okay, this one worked. So this is the one that ran in the PyCharm, in the so you can see it prints out the result, the top of the result for one account. You get a metric for each date, February 2nd, February 9th, February 16th, etc. And you can see that since this is the same customer, the numbers kind of track each other. It's going 85, 88, 89, and then he drops down. I guess he had a bad week here, and he goes down to only 70. So it just kind of follows along for one customer. Uh-oh, you had a fight with SQL Alchemy today. That does not sound good. Yeah, I had several fights with SQL Alchemy and like Postgres SQL tools when I was writing the book. I basically got one thing to work and then I just stuck with that because getting that stuff set up is a pain. So here's the result that we can see coming out of the query tool. So again, for customer 1, he's up in the 80s. Eventually we're going to get down to another customer here. Going through all the customer 1 metrics. Okay, here's customer 2. So he's a less liking individual. So he had like 22, then 34, and then we'll get through all the then we'll get to all the customer 3 metrics. So okay, this is looking good. So we calculated a lot of metrics for the customers all at once, and that made it much easier. And so next, we're going to go on to the next step, which is actually I said that we were going to calculate the metrics in the database, which also means we want to save them in the database. We don't just want to calculate one metric and then spit it out. We're actually going to save these metrics, and then you can use them again and again during the analysis. So I say aggregations, whoops, let me go back. We're doing an aggregation over customer and time. That was what I was just showing you. And then we're going to write them back into the metric table. And we're going to write them by account ID, metric time, so that then you can use them in the further types of analysis that we're going to do later. So, to do that, we will look at listing 3.3, which I think was the one I started telling people about earlier. So listing 3.3 again is similar, but it adds some new elements. I guess I'll just go ahead and run it. And then I will also dissect it for you. Actually, this one I'll probably just show you in the editor here in PyCharm, which is fine because it's going to take a little bit longer to run, and it's actually going to save some data. So here we go. I'm going to run it first, and then we'll see how long it takes. So here we are running it. So it's launched against my schema, and the result will print out something in a few minutes when it's done. Let's look at how this query is different from the previous ones, mainly by this important line here, which is the insert statement. This one line changes it from a query, which is going to show you the result, into something that's actually going to save the data back into the database. So this is called an insert select statement, if you haven't seen those before. So we do the same trick where we select a sequence of date vals that we're going to run the calculation for. And then we have this insert statement into a table called metric. And that's where we're going to save all the metrics. And into that table, we're going to put the account ID, the time of the measurement, which actually comes from, looks like, did we get our result? No result. Then we're going to also insert a name ID. So every metric needs an ID and the value for the metric. Now, how do we get all that into the select? Well, most of this query is the same as the one we were just looking at. But in the select statement, we've also got a bind variable for the new metric ID. So this is just like a constant that you insert in there as another bind variable. And then we've got a count star, which is the metric value. That's how many you actually count. So that's the measurement. And so yeah, it's the same group by as before. We group by account date and metric date. So we're counting the number of events of a given type within the last 28 days. And if we wait here for not too much longer, we will hopefully get a result. Well, let's get ready for the result by going back. Process finished with code 0. Okay, that means it should work. So how do we know it worked? Doesn't seem like it did anything. Let's go to the database and take a look. Do a new query. We'll just do select star from metric. Let's see what this does. Well, maybe we should put a limit. Do like a limit 100. on the rows from metric. Now, here you go. Do these numbers look familiar? This was the same query for account 1. We had those values in the 80s. Now you're seeing metric name ID 0 got placed into this column here. And eventually we'll get to customer 2. Yep, and remember customer 2 was in the 20s, so this is just the same result as the queries we were doing before, but now we've saved it all in the metric table. And we see it by selecting star from metric. And you can do like select star from metric where account ID equals 100 if you just want to look at one customer. All right, hey, look, customer 100 is in the hundreds. He likes hundreds of likes per month. Now, what about the name? So here we've only got this name ID, but let's see, what I call this function whenever a new record comes into the event table, like a trigger. Basically, well, I wouldn't personally do it whenever a new event comes into the table. I would do it periodically because I'm only suggesting it for this kind of application that you calculate the metrics once a week. You could calculate them much more frequently if your product was something where, you know, people are using it in a very, you know, well, if it's consumer use and people use it like really soon after they get it and they might churn fast, then you need to calculate metrics every day and keep the metrics up to date more. For many products, though, it's sufficient to calculate metrics every week because usually customer behavior doesn't change that fast, and usually people last a few months on a typical product, so it's adequate to update their data every week. So in that case, you would do a weekly batch job, or you could do a daily batch job also if you wanted to calculate the metrics every day. And if you real time would be unusual that I mean, many people talk about needing real-time information, but for the most part, you know, it's usually not quite that dire. Let's see. Trying to like reshape the viewing experience here. I think that's a little better. All right, we'll try to go with this. Hopefully everyone can see everything without me. I'm getting used to my new camera here, by the way. If you've watched my stream previously, I always had like a, you know, a camera showing, oh, bye Max Payne Life, gotta go. Nice to have you here today. Thanks for subscribing today also. You're awesome. All right, so I was telling you what we're gonna do next is actually put in the name in the table. So there's actually, okay, see you next time, bye. So there's actually a metric name table which is where we're gonna store these names. And that's right here, but there's nothing in it, right? So that's why we come to the next listing. Well, just go down. Metric name insert. It's very simple, actually, inserting the metric names. There's another query saved here, listing 3.4, which is how you can do the metric names. So you can see this is a very quick insert. Insert into metric name, new metric name ID, and it's very, very easy to insert the metric names. And if I was a better, you know, programmer, I'd probably like come up with some way to do this like automatically, but here I just have it as another little listing that you run very quick. We just do run listing 3.4, insert into metric name. That is very quick. So now if we go back to the database, we will see I have one listing in my metric name table, like per month. And that was going to be the first metric in the table. So we've got one metric and one metric name now, and so that's good. That's a good start. We now want to insert several other metrics. So maybe I should remind everyone about what all the events are. There's actually an event type. if we look at the event type table, you can see all the different events that are part of the simulation. Post, new friend, likes, ad views. So up to 6 and 7. So there's 8 different events. We've got 8 different metrics to calculate. So what we want to do is just run these all in one go without like repeatedly, editing these SQL files. And to do that, there's a way included in the book code, which is you run these different versions. So I think I'm actually going to go now and actually show you a little bit about how this configuration works, so it's not so sort of magical and mysterious. We'll do a little dive into the configuration of the code. So I'm saying here you're going to run chapter 3, and listings 3 and 4 were the ones that we just ran, in case you were paying attention. Listing 3 calculates the metric and inserts it, and listing 4 inserts the name into a table. Now I'm saying to add this flag, version 2345678, when you run the code. So that would be going here. I'm going to make a new configuration to this. Run listing 3, say .x. So now I'm going to duplicate this one and say, call this listing 3.star, because I'm going to say to do listing 3 and 4. You just put 2 numbers in the configuration. And then we say for the version 2, 3, 4, 5, 6, 7. Now those instructions are in the book. The book will just tell you, what book? This book, Fighting Churn With Data. These instructions are all in the book. It says just put in version 2, 3, 4, 5, 6, 7, hit go, and you're going to be done. So first I'm going to launch this query, because it's actually going to take a little while to calculate all those metrics. And then while they're calculating, we can spend a little time learning more about how it works. Maybe I should even put in some breakpoints. Yeah, we can maybe try to put a breakpoint in the wrapper program, which you find, the wrapper program that runs all this is in the Py folder under the listings. It's just run churn listing. I've actually got a breakpoint set already, which is right after printing the SQL. So let's run this in debug mode. Let's see if it works. So let's see. This is where it opens the SQL. So there's a parameter, you can see all these parameters, chapter 3, listing 3, the name is count metric insert, and this is going to open that file. I'll just show you this quickly. And the next part that's important is setting the parameters. So this loads the file, so now I have that SQL stored in this string variable. Actually, after this string manipulation, the SQL variable now has the entire string, which is this entire SQL, the selection. And now, very important, we're going to, let's see, we're going to replace the parameters. So this is where there's a dictionary here has those parameters that we need to run the SQL, including the start date, the end date, and the event to measure, in this case the new friend, and also the new metric ID that we're going to insert. So I'm going to let this go for now, and then it'll stop again before the next query. Let's see. All right, it's now running that query, and now we can actually spend some time looking at where do all those configurations come from. This will be going into the guts of like the wrapper program that comes with the book. There's a configuration file here, which actually has the configuration for all the listings. Has it concluded? Oh, it looks like it finished the first one. Well, I'm going to let this just keep going and run more listings, and we can take a look at the configuration. So I'm going to remove this breakpoint. I'm going to disable this breakpoint. We'll keep it around there. We might want to go back there. And now I'm just going to let this go and calculate, more and more metrics. So I was saying about the configuration, this JSON file actually controls how all the code is run in the book. So all the listings are written with bind variables, and that's to make it not hard-coded to this particular churn scenario and this particular database. And I used this same code for the real customer case studies. So in the book, there's the simulation, which I'm going through now in the stream, and there's also real customer case studies, which show you which show you the results when you run the code on live customer data, which I wasn't able to share with you. So I used the same code, and I would have a different configuration for each case study, including the simulated case study and the real case study. So the configuration is divided into chapters. And then within that, there's a default parameter block and then a block for each listing. So the defaults for chapter 3 are to use these start and end dates, February 2nd and May 10th, which you've been seeing in different places. I also put in a default event which works for the first 3 sequels. So for sequel 1, I actually don't even put in any parameters. There's just the name, which is really like a consistency check. And then the other parameters come from this default. But then when I'm running these other sequels, now when I get to the metric insert sequel 3, there's actually another level in the configuration, which is all these different versions. Version 1 through version 8. Ooh, looks like I had to go up to 8. Well, here's version 2. Because version 1 is actually a duplicate of the version 0, or the original. So when it's running these different metrics, it's picking the parameters out of this configuration. So it looks like it's up to dislike. So it's up to number 5. Moving along. So when it gets to number 5, it takes out the configuration, which is that the event to measure is dislike, and the new metric ID is number 4. So this is the parameters that are picked up and fed into the wrapper program. So let's see, how far have I gotten? Another way we could keep up on this, the progress of the metric inserts, is going back to the metric name, because as we go through each metric, it's inserting the name into this table. Oh, it's only done 0 so far? That's not good. Well, if this takes forever, I actually have another database where I've already done this. It might not update them until the very end. Let's see what it's saying out here. Okay, it was just running. I'm scrutinizing the output here. Well, it looks like it just ran for the event message. Whoops, hey, it looks like it's all done. I think I had one more to do, but let's just check. Now let's go back and look in the metric name table. All right, now we have several metric names. Likes, new friends, posts, ad views, dislike, unfriend, message. Okay, I think I missed reply. I gotta go back to my configuration. I just gotta run one more before I forget, or this will really screw me up later on. So I'm gonna edit this configuration, and I'm just gonna say, here's my version. I actually now just need to rerun version 8, because I missed that one the first time. My slide led me astray. It said do 2 through 7, when really it had to be 2 through 8. So now I'll just run that one. So now that version 8 is going to be the final event to measure, which is reply, and the final metric ID, which is 7. So that'll just finish in a few minutes. So it actually didn't take too long to calculate all those customer metrics. Now, how many customer metrics did we calculate? Let's take a quick look. How many customer metrics did we calculate? Let's see, what were we doing? Select star from metric. Let's do select count star from metric. We'll do a group by metric name ID. Let's just do this to get it working. All right, so we calculated a bunch of, looks like I need the name IDs, or we can't tell anything here. Name ID count star. All right, so we are calculating, looks like about 160,000 of this first one. It's a little bit hard to read. We can't see what exactly the events are here. So I'm going to go from, I'm actually going to add a join because we have that metric name table. So we'll do metric inner join metric name. I'll give them the aliases M and N. On M dot, they join by the ID. This is a standard, using an ID to join the column. Let's see. So now we'll select metric name so we can see how many metrics of each name type there are. All right, so we can see ad views per month, we've got 160,000, dislikes per month, 150,000, message per month, etc., etc. So these are all mostly, well, unfriend per month has the fewest. Unfriend per month. Let's see, and how many results? We got 8 results, so I think this is actually right. Going back to PyCharm, yeah, looks like everything finished. So now I have successfully calculated all the metrics from this section of chapter 3. So let's see, the next thing we do is after calculating a bunch of metrics, the next thing you have to do is check the data and make sure that it actually looks good, that the metrics that you calculated make sense. So to do that, I'm going to show you a few different quality assurance techniques. And that's basically, I think, going to be the rest of the stream for today. So this was, again, running multiple metric inserts in the wrapper program. We also took a little detour to look at where all these versions for the different listings are stored and configured. So that was run the metrics. Okay, I just did that. That's what we were doing. And the next thing we're going to do is we're going to make time series quality assurance for the metrics. And this is actually an aggregate time series of statistics of the metrics. And this is an example from a real case study, just showing you what the type of plot we're going to make looks like. And then in just a sec, we're going to get into the SQL and the Python that will actually calculate these. So the maximum metric value over all customers is very interesting to look at. And here you can see for this metric, that text might be too small, but it's like 100 to 300. And the average metric value for this case study, this is again, real customer data case study. The average for this case, you can see there's this build-up period when you start out from no data. You start building up observation of the metric. So here you can see once you get past the build-up period, the average value is around 6. Here the minimum value is 1, it never changes. And then lastly, this is the count of the number of customers that you calculated for. So this type of chart is a really useful quality assurance just to give you an overview of your metrics and also to help you catch if there's any weird issues in your data. So how do we do this? It's actually a 2-step process. First, we run a SQL which calculates the metric stats. So let's take a look at that. And this is a good way to get a summary of your metrics. As usual, I will go into my wrapper program that runs these. I'm just going to update this to do listing 6. So this is chapter 3, listing 6 from Fighting Churn with Data. I'll just run it, and then I think in this case, again, we're going to take the SQL and put it in the SQL editor to do it. So this one actually saves the results. It just saved it. We'll look at what it saved in a minute, but let's actually go through the SQL first. And again, I'm going to do that by putting it here in my SQL editor. I'll make this a little bit bigger. So once again, I'm selecting over a date range using, this is Postgres, so I'm using the generate series function. As we were discussing earlier, there are different ways to do this. The simplest way is just to create a permanent table in your schema that has the date sequence you want to use. As I mentioned, I calculated the metric 7 days apart. So when I do this dated QA, I'm also doing these 7 days apart. So let's see, we select the metric using the bind variable here, and then we do a join with the metric values and the date series, and on each date we do a group by, so this is an aggregation, and calculate the average, the count, the min, and the max of the metric. Now if you're thinking those are just the fields we were looking at in this QA plot, you're right. So here's how we collect the data for the QA plot. Whoops. Oh, this is the I've got some of the code selected bug, where if you select anything, it thinks you want to run that, even if it's only one word. All right, now let's execute the statement. Appears to be working. Okay, so this is kind of showing long numbers, but you've got each date, February 2nd, February 9th, February 16th, and for each of those, we calculate all the statistics. The average, the number of calculated, meaning the number of metrics that were inserted into the database, and the minimum and the max. Now I told you what I did is I actually saved this into a file. Oh, let's see, I didn't actually prepare to show you any files, but let's do that. I will get a window open on my Finder. We'll go to where this stream dev lives. Now, if you installed the code, from my book, in the recommended way, you'll get this output directory parallel to your, to the one where you're running things. And so this is the metric stats file that was just created. I don't know if you can see this, but it says it was made today at 4 p.m., which is in my time zone. All right, I'll try opening this up. Sometimes this screws up Streamlabs, actually. This is risky. If my stream goes offline, it's because of Microsoft Excel. All right, it didn't go offline. It did open up the file in the wrong window, but that's fine. I'll just bring it over for you to see it. So this is the complete output of that metric stats over time query, and it's just a little table that has all the numbers. So there's not really that much to it. And this is actually not a bad way. You could actually make that visualization that I was just showing you here in Microsoft Excel. Actually, should I demonstrate? Here's a quick Microsoft Excel demonstration. I don't know if anyone's actually into this. I'm going to lose viewers because they're like, I thought this was coding, not looking at Microsoft Excel. But you can easily look at this same data in Microsoft Excel. And that's kind of one of the reasons I save it to CSV, because it's a great way to share the data actually with your business colleagues. But we want to visualize it in a nicer way. What about Jupyter? Yes, we should do this in Jupyter. The truth is I'm not a very expert at using Jupyter. And well, there's a reason I don't advocate it for actually putting this code into practice, and that's because your co-workers at your company almost definitely don't have Jupyter notebooks unless you actually work at a data science company, like a company that makes a data science product. then maybe everyone will have Jupyter notebooks. But I work at a normal company where we make enterprise software, and only the data scientists might have a Jupyter notebook installed. But all the time I have to share this data with the business people. So that's why I don't really focus on Jupyter notebooks, because at the end of the day, the real people you need to work with are not other data scientists. They're just other, they're other people in the business. And do they have Jupyter notebooks? No way. Do they have Excel? Yes, everyone in your business will have Excel. And I mean the people in the marketing department, product management, sales, customer support, they're all going to want to see the data in Excel. I'm sure that will change and other people will have Jupyter. I don't know, maybe. It's really Jupyter is used commonly in data science education. So let's do the visualization in Python anyway. So let's go back. So I don't actually recommend visualizing this. We actually do a visualization in Python, and we have code for that. So this was the first we do a SQL to collect the metric stats, and next we plot it with the metric QA plot.py. So let's get into some of this Python code now. Now I'm going to go to listing, I think it was 3.7. Let's open it up and put a breakpoint, because it'll be so fun to actually step through some Python code. Seriously, because we've been doing all this SQL. I actually like going through the Python code more. It's easier to, you can go through it in the debugger and really show people. So listing 3.7 is one of the first Python programs taught in the book, and it's just to make a simple plot. So it's honestly pretty basic. I'm just going to debug into it. It should only take a second. Here we are. So on the first line, we've got the path as a parameter. We've got a path, the metric name. Let's see that we can see, where's our metric name parameter? Oh, I have to go one more line. Am I crashing? Oh no, I'm crashing. I wonder what I did wrong here. All right, it's live debugging, the best part of every stream. WTF. Why did this crash? Import no module name listing 3.7 metric QA plot. This seems to be a problem with my, what is this a problem with? I thought I made it in the debugger to get here. It might, let me check my preferences. Yeah, it seems like a Python path thing, but I was supposed to set that up in the project settings, because I'm doing this in, let's see. Oh yeah, I didn't add chapter 3. That's it. It's a Python path problem. Thank you, Musfit. Quite right. And this is how you set up your this is a mark as source. I need to get to the folder that I want, which is chapter 3, and mark it as a source. And now it appears over here. So this is the equivalent of adding something to your Python path done in the PyCharm integrated development environment. And as you can see, I screwed it up when I did my original setup. I missed chapter 3. All right, now let's see if this works. All right, let's see if I can make it to my breakpoint now. There we go. Okay. All right, well, we navigated that little debugging issue pretty easily. So now this is a very simple Python function. I'm sorry to disappoint the Python aficionados. We get into much better Python later on in the book. But we've got a metric name, and in this case it was like per month. That was the metric we're calculating for. It figures out the path to that file, because I gave it this overall path. So then we're going to load the data, hopefully, into, whoops, it's crashing. More live debugging. All right, now what? Let's see. Oh, it's still trying to use the path SocialNet 7. Now this is supposed to be SocialNet 1. I think I have to fix this in my configuration. see. Yeah, see, it's here in my. This is because I made a new schema name. I'm not using the standard schema name, and this is what you have to do if you make your own schema name for the book. I think I'm just going to do a quick replace all in that JSON file. Save it, and go back to the debugger. All right, so these configurations, here we are. This is actually chapter 3. I'm going to close up. Here we are in chapter 3, listing 7, and you see you've got to give it the path to where it's going to find that file. And it could be different things, you know, for different people. I do it, it's set up here to be, like I mentioned, a path that's next to the code. So my code is in these folders. It's in this Fight Churn 1 folder, and Fight Churn output is the folder next to it where I put it. Now I've actually got, you know, outputs for 2 different schemas. Each schema gets its own folder. So now here's my actual path. So now I've changed that in the configuration, and hopefully it's going to work now. There you go, get my crossed fingers on the screen. All right, 3rd time's the charm. Chapter 3, listing 7. Now, hopefully, when I run this line, I'm going to use pandas read CSV to load my data. And it worked. All right, let's verify. Let's look at the QA data frame. So this is that little table I was just showing you, as you may remember. This is the table that was saved. We've got the calculation date, the average, the number of calculated, the min and the max. All right, so the rest of this is just using matplotlib, the plot function. We are using subplots here. So I define a figure. Let's see, let's move it over so it's like, how can I get this on the screen? 1 second, here's the figure. But I need to actually click on the debugger. This is not working. It's like, it won't let me. Okay. This is not, okay, maybe over here. If I can just scroll down. All right. Here we go. Now I'm making one plot. Okay, there I made one plot. Now I added the title, like per month. Now we make another subplot and another subplot. And then I hope it's, and then, okay, we do the most important call, which is cleaning up the axes. And then we also save it to a file. And we're basically done. Now, if you did set this up in a notebook, yeah, no, Jupyter would be a great idea for this. And I would actually like help. So Mostvit, maybe you could help. I don't give instructions to set up Jupyter to run the book code. But I would be really open. It would be great to use Jupyter for things like this, where you produce a plot. So the way I've got it set up, not ideal. Whoops. We have to go back to the folder where we're saving everything. Let's see if I can find my plot now. Here's the plot that we just saved. Whoops, once again, it's opening up in the wrong window. Here you go. So here's the plot that we just saved. And that's the QA for, oh, you know that you mailed me? Uh-oh, I better look for it. If it was my work email, I don't check that on the weekend. So I'll totally look for it. Let's see. So this is creating that one plot, like per month. And you can see that the maximum likes per month is actually pretty high, up around 4,000. Wow, someone really likes stuff a lot. The average is just around 100, and you can see there's like the build-up period at the beginning where the reason you've got that is because if you imagine a 4-week window at the very start of your data, it's only going to be looking at a short history. So these people, this is only like a 1-week history, you know, and then as you get more people in, as you get more history, you don't have so many zeros averaging it, bringing down the average. You can see here the minimum is 1. That's because we only calculate the metric for people who have 1 or more events. And then there's around 10,000 likes per month. Okay, so that's all very well and good. How can we do this more efficiently? Well, I already showed you how to run more than one thing at a time with the wrapper program. So let's do that. So now that was you doing listings 6 and 7, if you recall. So 3.6 saves the stats with SQL. 3.7 actually does the plot with the QA. So I'm going to go back to my 3.star listing runner. Whoops, I actually want to edit it. And now we're going to do 6 and 7. Now I need to get my version numbers. So there are version numbers for this too. Let's see. I'll go back to the configuration file. Whoops. That's not where I'm going to get the file. So my configuration is again in conf socialnetlistings.json. So let's see. So for listings 6 and 7, I again have versions 1 through 8. It looks like. Okay. Yeah, so I actually want to do 2 through 8. So it's actually the same as the other listing. These actually match. So there's a method to my madness. So if I just go back into here and edit the configuration, this should be version, you have to list them all, 2, 3, 4, 5, 6, 7, 8, listings 6 and 7. So by running this, it should just crank out all those plots for me and save them to that folder where we were just looking. It does each query and then does each plot. If I go back out to the folder, we're going to see those plots appearing and those files. Well, kind of like, there we go. This is a better way to look at it. All right. Let's see, here are the files. I'm just going to open a bunch of these. Wait, I want to open actually all the plots that are PNGs, and then we can look at the stats for all these metrics. Let's see. Okay, so now here we have all these other plots. So for each metric, now we can see for ad views, the average, or the maximum is above 1,000, the average is around 40. For dislikes, you can see the maximum fluctuates around 500, the average is between 10 and 20, and messages per month. So this is like a time series QA. To be honest, the time series QA is not that interesting for the simulation. And that's because, I mean, my simulation is just not that realistic, and there's no missing or bad data in it. I think on the next stream, I'm going to work on creating a version that has like some missing or bad data so we can get some more value from the QA. Or maybe in a few minutes I could just like delete some metrics to show you what it looks like. So you can see all these plots for post, reply, and lastly, unfriend. Unfriend is actually the least common event. You can see the maximum is only around 4 to 5 per month, and the average is just above 1. And actually, if you look, only about 2,000 accounts, or just over 2,000 accounts, actually get the metric at any given time. So that means a lot of customers don't get the unfriend per month. Excuse me. But this is not actually the most efficient way to do this kind of quality assurance. Well, to check for this, like, how many customers have the different metrics, because now we have to like look across all these different plots to see, okay, this one 5,000 customers get it, this one 10,000 customers get it. The next QA in the book is actually to do one combined QA, and that will be, I think, the final listing that we'll do on today's stream. Well, actually, I don't think I made any slide for this listing, so I'm just going to go to it. Pretty sure it's the next one. It's going to be listing 3.8. And it's called metric coverage because it's going to do a query to actually check what % of accounts get each metric or coverage. So that's kind of like what I call the metric coverage. And it will also do some other aggregate stats on the metrics as well. So once again, the query has a start date and an end date. And then in this little CTE, it actually counts the number of accounts. You know what? Let me run the query, and then we can break it apart in the SQL editor. So first, let's just run it. Update the configuration to run listing 8, chapter 3. As usual, that'll print out the query that it's running at the same time as it starts running it. And I will copy the query with all the bind variables already filled in over to my trusty, or mostly trusty SQL tool. And this will be a good way to look at what the query is actually doing. So, as usual, we select a date range. Here's select star from date range. Actually, this is just a beginning and end date. It's a very boring statement. Let's go back and put the whole thing back in. Let's actually select star from the account count. So what am I doing here in this first part? I'm actually literally just counting the number of accounts that are active at the right time. So this is the number of accounts, select distinct account ID, with subscriptions that start before the end date and end after the start date. So quick count, whoops, don't run the query when you're selecting anything. And let's see, whoops, select star from, going too fast. So this is the number of accounts that are active in this period. Can the min make sense anyhow? Sorry, I missed that question. Let me just get through running the rest of this query. So this just gives the count of the accounts. The rest of this is actually a standard aggregation. So we have all these aggregate stats on the metric value, and we're doing a group by metric name. So we group by, and also the number of accounts from that earlier CTE. And then to do the actual metric coverage, which is like the percentage of accounts that are active on one day, I count the distinct account ID. This is the count that has the metric from the metric table. And then I divide that on this line by the total number of accounts. So this is actually the whole query. This aggregation is the important part. We do a join on the metric name table so that we only get the, so that we can get the name into it. And then we also do a inner join on subscription so that we only get the subscriptions that are active in the right period of time. Whoops. Once again, can't execute when I've selected anything. Okay, so the min chart. Yeah, I remember the min chart. We can this query is running. We'll give it a few minutes. Oh, well, there it goes. There's the query results. You can see it gives you the ad view per month, the count with a metric, the number of accounts, and then the percent of the accounts that has the metric is just one divided by the other. The output is also saved, as usual, in a CSV file. And again, why do I save it in a CSV file? This is actually to make it easy to share with your business colleagues. So here's the metric coverage result in a CSV file, which, and what you would do is you would open this up in Excel. Uh-oh, am I crashing? Wow, I thought I was crashing there for a minute. Am I still live? Oh, my camera crashed. That's what crashed. Wow, how embarrassing, but it's not me, man. Loading the chroma cam. Here we go. Well, that's what happens when your chroma cam crashes in the middle of your stream. Looks like my sound never went out and everything's okay, but note to self, opening Microsoft Excel can crash chroma cam. which is the camera utility that I'm using. But anyway, so this is the result of that query shown in a spreadsheet, which would be suitable for sharing with your business colleagues. And it makes it easy to format, so now I can also do things like format this as a percentage and get rid of the extraneous decimal places in this other chart. So now we can actually see, let me also make the names more visible. So this column is the percent of accounts that actually have the metric during the measurement period. And as I told you, that's the division of this column B, count with metric, by the total number of accounts. And a great way to visualize this is with a little conditional formatting. So having a lot of accounts with the metric is good. So only one gets highlighted in red, and that's unfriend per month. We can also see what metrics people do the most of just by comparing these average values, and also giving it a little color highlighting makes it easy. Again, makes it more exciting for your business friends. So I usually do a little formatting on these, and then I share it with my business coworkers. So now I could go back and report to my business coworkers that the most common event is liking, and after that come posting, messages, and viewing ads. And then some less common events are dislikes and replies. And the least common event is the unfriends. Now these also go along with the percent with the metric. So the lowest percent with the metric is also the lowest in the average value, which makes sense because these are simple counts. And so also shown here are the minimum and the maximum, which is kind of like what we were seeing in the other table. So this is like a table, one quick snapshot summary of everything that was in the QA. And again, this was listing 3.8 from chapter 3 in Fighting Churn with Data. Yeah. So that actually covers all of the basic metric calculation in this stream. And I think that's where we wrap it up for today. Let's see, was there anything else I was supposed to talk about? Nope. See, here's the summary. So let's see, summary. Fighting churn is about targeted interventions, which include, good idea about the box plot, but let me just go through my summary. We can address the box plot first, actually. So MOSFET, you're saying to make a box plot for each metric would be a really great idea, actually. You could make a series of box plots in one chart, and that would be like a good summary of this data. Showing, the average or the median, and then whiskers for the minimum or maximum. So that would be great. Although I'll tell you again, the problem with box plots is that your data scientists like me and statisticians, we love box plots, but business people really don't know them. I've actually tried this. So honestly, I have taken box plots into meetings with business people and been like, oh, this box plot summarizes the distribution or, shows you the values. And people are like, huh? What do the lines mean? So actually,